Subject name is Engineering Mechanics. Subject code is 23MEC102. My name is C. Lakshmi Prasanna. My roll number is 234G1A0115. Branch Civil Engineering. Define polar moment of inertia. The polar moment of inertia, also known as second polar moment of area, is a measure of an object's ability to resist torsion twisting about an axis. It is denoted by J and is used in the analysis of structures subjected to torsional loads. For a given cross-sectional area, it quantifies how the area is disturbed with respect to the axis of rotation. Mathematically, for a given area A in a plane, the polar moment of inertia about a point, typically the center or an axis, is defined as J is equals to int A x bar 2 plus y bar 2 dA. The given composite section can be divided into two rectangles as follows. Area A1 is equals to 150 into 10 is equals to 1500 meters square. Area A2 is equals to 140 into 10 is equals to 1400 meters square. Total area A is equals to A1 plus A2 is equals to 2900 meters square. Due to symmetrically centered lies on the symmetric axis y minus y. The distance of the centered from the topmost fiber is given by y is equals to sum of movement of the areas about the topmost fiber by total area is equals to 1500 into 5 plus 1400 into 10 plus 70 by 2900 is equals to 41.21 millimeters. Referring to the centroidal axis x bar x and y bar y minus y, the centroid of A1 is G1 0.03621 and that of A2 is G2 0.0 minus 38.79. Moment of inertia of the section about x minus x axis. X into x is equals to moment of inertia of A1 about x minus x axis plus moment of inertia of A2 about x minus x axis. Ixs is equals to 150 into 10 cube by 12 plus 1536.21 whole square plus 10 into 140 cube by 12 plus 1438.79 whole square. Ixs is equals to 637244.2.5 millimeter to the power of 4. Similarly, Iyy is equals to 10 into 150 cube by 12 plus 140 into 10 cube by 12 24.166.7 millimeter to the power of 4. Hence, the moment of inertia of the section about an axis passing through the centroid and parallel to the topmost fiber is 637244.2.5 millimeter to the power of 4, and moment of inertia of the section about the axis of symmetry is 2824.166.66 millimeter to the power of 4. The radius of gyration is given by K is equals to root I by A. Kxs is equals to root Ixs by A is equals to root 637244.2.5 by 2900. Kxs is equals to 46.88 millimeter. Kyy is equals to root 2824.166.66 by 2900. Kyy is equals to 31.21 millimeter. Define angular velocity. Angular velocity is a vector quantity that presents the rate of rotation of an object around a particular axis. It specifies how fast an object rotates or revolves relative to another point, typically the center of a circular path or the axis of rotation. The angular omega is defined as the rate of change of the angular displacement theta with respect to time. Theta omega frac d theta dt. A man weighing 637 newtons drives into a swimming pool from a tower of height 19.6 meters. He was found to go down in water by 2 meters and then started rising. Find the average resistance of water, neglect the resistance of air. Given that W is equals to 637 newtons, height is equals to 19.6 meters, S is equals to 2 meters, G is equals to 9.8 meter by second square. Let Fr is equals to average resistance. Initial velocity of man U is equals to 0. V square is equals to U square plus 2GH is equals to 0 plus 2 into 9.8 into 9.6. V is equals to 9.6 meters by second. Now distance travelled in water 2 meters. V is equals to 0. U is equals to 9.6 meters by second. Now apply V square is equals to U square minus 2AS. V square 0 is equals to 96.04 meter by second square. In equation 2, since net force acting on the man in the upward direction Fr minus W, but the net force acting on the man must be equal to the product of mass and reduction. Fr is equals to Fr minus W is equals to Ma. Fr minus 637 is equals to 630 by G into 96.04. Fr is equals to 6879.6 Newton. State the work energy equation for translation. The work energy equation for translational motion states that the work done by all external forces on a particular particle or a rigid body is equal to the change in its kinetic energy. Mathematically, this is expressed as W is equal to delta Ke, where W is the total work done by the external forces, delta Ke is the change in kinetic energy of the body. Two blocks of weight W1 and W2 are connected by indexible wire passing over a smooth pulley as in the figure. If Wn is greater than W2, find the tension in the string and the acceleration of the system. Let M1 is equals to W1 by 2, W is equals to Mg, M2 is equals to W2 by G, M2G is equals to M2A minus G, P is equals to M into G is equals to M into A plus G, M2G minus M1G plus M2A plus M2G plus M1A plus M1G, 2M2G 2M1G plus A M1 plus M2, 2G M2 minus M1 is equals to A M2 plus M1. A is equals to 2G M2 minus M1 by M2 plus M1 by equation 1 and 2 and 3. T is equals to M1G plus M1A plus M1G plus is equals to M is equals to 2G plus A is equals to Wn by G, 2G plus 2G M2 minus M1 by M2 plus M1 is equals to W into 2M2 M1 plus 2M2 M1 by M2 plus M1. W is equals to W 4 W2 by G, W by G, 4 W1 W2 plus by W1 plus W2. Tension in the string is 4 W1 W2 by W1 plus W2 into N. Thank you.